Chapter 8.3, Special Right Triangles. The first triangle we're going to look at is a 45, 45, 90. Since the two angles here are congruent, we know by the converse of the isosceles triangle theorem, the two sides are congruent. So when we have that case, we have where we know the sides here are congruent, we have a right angle, then the hypotenuse is going to be a rad 2. How that came about is if you look at a right triangle, and this is length 1, and this is length 1, and we want to find the hypotenuse, we know that x squared would equal 1 squared plus 1 squared. So x squared equals 1 plus 1, which is 2. So x would equal plus or minus rad 2. So this side here would be 1 rad 2. Doesn't matter what the sides are. For example, if I change this to 3 and 3 and apply the Pythagorean theorem again to find the hypotenuse, I would have x squared equals 3 squared plus 3 squared. So x squared equals 9 plus 9. X squared equals 18. So if I look at 18, that'd be 2, which gives us 9, 3, and 3. That would give us that x equals plus or minus 3 rad 2. Looking at the first problem, we're given this is 45 degrees, which makes this one 45 degrees also. So we have a 45, 45, 90. This side is 9. This side would be 9. And we have the pattern that says A, and A rad 2. So this side here would be 9 rad 2. Here again, we're given that the two sides are congruent, which makes these two angles congruent. So we have a 45, 45, 90. This side would be A, and A rad 2. So x would equal A, which is 6 rad 2, times rad 2. X would be 6 times 2, because rad 2 times rad 2 is 2. So x would equal 12. On the next one, we're given that it's a 45, 45, which makes the sides congruent, and we're given the hypotenuse right now. So if this was A, that's A. This is A rad 2. So A rad 2 equals 8. Divide both sides by rad 2. Rationalize the denominator, because we cannot have a rad in the denominator or square root. We would have that A equals 8 times rad 2. Rad 2 times rad 2 gives us 2. So the sides would be 4 rad 2. So both of these would be 4 rad 2. In the next problem, we have that the hypotenuse is 6, and both of the sides are congruent. So if this is B and this is B, this would have to be B rad 2. So B rad 2 equals 6. Divide both sides by rad 2. Rationalize. So we'd have 6 rad 2 over 2. So B would equal 3 rad 2. The second special right triangle that we're looking at is a 30, 60, 90. And for this one, we have the pattern that the side that's the closest to the 60, that's a leg, not the hypotenuse, is x. The hypotenuse is 2x, and the remaining leg, which is adjacent to the 30-degree angle, is x rad 3. Looking at this picture, we would have A, 2A, and A rad 3. 5 is our A, 2 times 5 is 10, and 5 times rad 3. So let's look at the first problem. This is a 60-degree angle. So this is our A, this is our 2A, and this is A rad 3. So x would equal 2 times A, so 2 times 11, which is 22. And the reason this one is A is because it's adjacent to the 60-degree angle and not the hypotenuse. Y would equal A rad 3, our A was 11, so 11 rad 3. So x is 22, y is 11 rad 3. In the next problem, this is the side that's adjacent to the 60-degree angle, so this is A. This would be 2A. And y would be A rad 3. So if 30 is 2A, A would be 15. So x would equal 15. And if this here for y is A rad 3, we solve for A here, so it'd be 15 rad 3. This would be our 60-degree angle. So this would be A, 2A, and A rad 3. So y would be 2 times A, which is 5 rad 3. So y would equal 10 rad 3. X is A rad 3. A was 5 rad 3 and rad 3. So this is A rad 3. Rad 3 times rad 3 is 3. So x would equal 15. This here is our 60-degree angle, and I know the picture doesn't look correct, but you have to go with the flow because that's what they're teaching you to see if you can recognize what's close to the 60-degree angle. This would be A. This would be A rad 3, and x would be 2A. So x would be 2 times 21 rad 3. So x would equal 42 rad 3. Y would be A rad 3. A is 21 rad 3. Rad 3. So again, this is A rad 3. So y would equal 21 times 3. So y equals 63. The next problem says that we have an equilateral triangle, and if you review what an equilateral triangle is, all the sides are congruent and each of the angles are 60 degrees. So all angles are 60 degrees. If we look at an equilateral triangle and at the altitude, which goes from the vertex to the opposite side perpendicular, each of these angles here would be 60 degrees. All the sides would be congruent. In an equilateral triangle, the altitude cuts the base into 2 equal portions and the angle into 2 equal portions. So we have a 30, 60, 90. We know that the altitude is 27. This would be A, this would be 2A, and 27 would be A rad 3. So we're looking at this triangle right here. That's 60. This would be A, this would be 2A, and 2A would be the length of a side. And this 27 would be the A rad 3. So A rad 3 equals 27. Divide both sides by rad 3. Rationalize the denominator. So we're going to multiply top and bottom by rad 3. So we end up with A equals 27 rad 3 divided by 3, because rad 3 times rad 3 is 3. So A would equal 27 divided by 3 is 9, 9 rad 3. So this portion right here is 9 rad 3, which is half the length of a side. We know our sides would be this whole length, which is 2A. So the side is 2 times 9 rad 3, which is 18 rad 3. And that concludes our lesson 483.